Yes, I'm going to be talking about the Toyota Prius Plug-in Conversion that I've done on our Prius. Or I should say my wife's Prius. I get to drive it every now and again, but she drives it every day for her work and her grandchildren, or our grandchildren. That's the beast there. It's basically produced in 2008. It's the same body shape from 2004 to early 2009. Can you see through me all right there? What's wrong with the standard Prius? Well, nothing. It's a great little car. Very comfortable. It's got all the modern features. Good fuel economy. Before I converted it, we're getting 4.4 litres per 100 kilometres. So with a 45 litre tank, you can calculate that's over 1,000 kilometres on one tank. But I would like to do better. Standard Prius, 1.5 litre petrol engine, 57 kilowatts. Electric system is 500 volts. They actually have an up converter from the around about 250 volts up to 500 volts to work the electric system. The electric motor is relatively small at 50 kilowatts. And this is one of the reasons why when you do any sort of conversion on a Prius, you can't run just the electric motor all the time. It's not powerful enough to get up hills and fast acceleration. You'll notice most of the electric vehicles or the extended range electric vehicles or the plug-in hybrid like the Holden, that's got a much bigger electric motor, and most of them are at least 100 kilowatts or more, with a one-speed planetary gear transmission. It's all technical. So the battery is the original battery is a nickel metal hydride battery, and based on 28 modules made up of 6 individual 1.2 volt cells, 6.5 ampere hour cells. You'll see it later on. You'll see a picture of this battery with the cover off, and you can get a bit of an idea of the cells. Storage capacity is interesting. It's only 1.3 kilowatt hours when you consider an AEVA is 16. But they only use 0.52 kilowatt hours of that. So they're not using very much of it, and the reason they're using only a very small amount of that is that the battery lasts a long time. They basically go between 40% state of charge to 80% state of charge. So they're not overcharging, and they're not over discharging. Why not buy a plug-in Prius? It would be nice, but you can't in Australia anyway. They sell them in Europe and America and Japan. And the battery pack then would be 4.5 kilowatt hours. But how much of that would they be using? You can buy a Holden Volt at the moment if you're quick. The new series, which has everything improved, is not coming to Australia. But it's too expensive anyway. After looking at alternatives, I took up plug-in supply in California's 10 kilowatt, they call it a 10 kilowatt kit, it's actually 10 kilowatt hours, but they call it the 10 kilowatt kit. And what you get with that, if you can buy the whole lot from them. You can buy batteries and battery cases and everything from them if you want, and pay for the freight to come over from America to Australia. What I bought from them was the front controller, the rear controller, and the contactor box. And the front controller sits at the front of the car. I can show you after. I've got the car out here. That connects into the OBD2 port of the car, of the computer, and that's got a data cable which connects to the rear contactor box, and then the rear contactor box is controlled by the rear controller. And I also bought some of the high voltage cabling as well from them, and it just happens to be the right length, which is good. What I purchased in Australia was the batteries. I bought 40 ampere hour Winston batteries. They're like the old, what was it? Thunder Skies, that's right. 76 of those, and of course because I've got 76 of those, I also have to get 76 BMS modules from EV Power. And I have a friend who runs Hammett Precision Engineering, and he owed me a bit of a favour. He actually made me the battery frame, which I'll show you soon. Okay, the front controller, it's got all these wires coming out of it. OBD2 port, the top one is the patch cable going from the front to the rear. The one up on the top left is the cable which goes into, I'll show you a little bit later, it goes onto one of the plugs behind the glove box, and it's the same with the EV switch. You actually have to cut wires and so forth in there and just join them on. Front of the box has got an on-off switch, turns the whole system off, and the interesting one on the left is called an ice kill switch, so the internal combustion engine can actually be killed. Now I mentioned before that the Prius motor by itself is not strong enough for hard acceleration and for hills. But if you're on the flat in the Adelaide metro area, you can push that button and the petrol engine will not start. And so you then have a range of around about, I haven't checked that yet, but probably a range of up to nearly 80 kilometres on just the 10 kilowatt hour battery. The rear controller and high voltage cable, that comes with a little plug pack, and the plug pack plugs into the 240 volts where it comes into the charger. So I've got a little distribution panel there to distribute 240 volts. That's got some requirements to, while it's charging, the board needs power on it, so you've got to have 12 volt power coming from the 240 volt in when the car's turned off. Various other connections, they actually, one of them not even shown there. There's a plug which goes to the rear contactor box. One of the other pair go to the BMS system. So your modules, and people might not realise, but your BMS modules have got like a loop, series loop, going through the whole lot, and the loop is actually applied to that rear controller box, and that's got the control in there to turn off your charger when the first cell gets to your high voltage point. So you don't have to have a separate BMS controller, which is really good. And that high voltage cable wrapped around the whole lot, that's the one I'll show you in a minute. That gets connected to the OEM battery. Contactor box, it's pretty hard to see there. There's two contactors there, and in the middle there's a little relay for to turn the charger on and off, to disconnect the charger basically when the car's running. And that's controlled from that 12 volt adapter plug pack. How does it work? Well, the Prius, like I said, the Prius remains a hybrid for most of the time. With this conversion, you don't even open the bonnet on the car. It's just all done from the back of the car. The front controller monitors the state of charge messages in the car computer via the OBD2 port, and connecting the additional 10 kilowatt hour pack as required. I found out from Rob, the manufacturer of these in California, a few little bits about how it works. I thought what was going to happen was the additional battery was going to be clipped across via the contactors to the OEM battery and just left. But no, it doesn't do that. That would cause problems with the system. What they do, the system within the front controller box tries to keep the OEM battery at 62%, so either side of 62. When it goes a bit higher, there's probably some sort of tolerance on that, otherwise it'll be switching every 2 seconds, which is the optimum. I've read that also in the I think in one of the Prius manuals they talk about 62% being the optimum value to keep the battery at, probably for length of life. Then what they call state of charge spoofing or spoof the car computer at around 80%. So it actually, the computer thinks the battery is at 80% the whole time. And in actual fact, the little bar graph display in the Prius is, when the kit's turned on, is green all the time. So the car computer thinks that it's 80%, even though it's 62. At the same time, the front controller tries to enable the EV mode, so you don't have to push the EV button, it does it for you from inside the box via the OBD2 port. Oh, sorry, no, via the EV switch connection, which I'll show you in a sec. Okay. I spoke about that before, the pushing the button disables the petrol engine. For that driving session, the only way to reset it is to actually stop the car fully, turn it off, and then restart the car, and then the petrol engine will run again. I looked up the circuit diagram for where he puts this wire in, and it's actually the power supply to the engine control module. So he just switches it off, basically. I'm not sure what the petrol consumption is. It's only been running for a very short time on this. We're getting around about 2.8 litres per 100 kilometres, which is still very good, because there's still a lot of hill work being done and a lot of high-speed work to visit our grandchildren. Okay, connecting to the OEM battery, I'll just run through this quickly. It's not super technical, but it just shows you what's involved. The Prius has got a safety plug, which when you pull it out, it's actually disconnects the centre of the battery, of the main pack. So the end terminals, if you touch both end terminals of the battery, you won't feel anything, because the centre has been disconnected. Okay, so they've converted into 2 battery packs while that plugs out. That plug also includes a built-in fuse between those 2 terminals. Okay, that's what the OEM battery pack looks like in the boot. When you take the black tray out of the boot, you can see the cover there. Whoops! You can see the cover of the battery pack there. That's where normally where the spare wheel sits, but not anymore, as you'll see later. That's with the cover off, and you can see each of these individual cells. So they're all in series. They're the 2 wires. That's the end of the high voltage connectors that you saw in the previous photo. One red, one black. That's where the black one goes. That's where the red one goes. And then they're fed up through here down to the back of the car, ready to be connected to the contactor box.
So how do those cells compare to what you've put in size form factor of those?
Well, they're 6.5 ampere hour, 1.2 volt. Well, that's 1.3 kilowatt hours.
No, physically, dimension.
Oh, I don't know. You'll see in a minute, because you'll see where the other battery pack goes. You'll be able to compare. It's about a third, maybe a third of the size of my pack, but only 1.3 kilowatt hours. And the cover's back on after you're finished. Made it look really easy. There's actually 2 or 3 other covers that come off as well. Okay, now to connect the front controller box, I mentioned there's one goes to the OBD2 port, that's just under the steering wheel. There's 2 connections into these bunch of connectors here, and they just happen to be behind the glove box. The glove box is really easy to get out, ridiculously easy to get out. No screws involved. Just push the sides in, lift it out, hook the little there's a little gas cylinder thing there, and then it all comes out. It actually just hooks on these front bits here. Hooks on there. Yeah, so there's 2 connectors in here that have to be connected to. One gets connected to and the earth, and the other one gets cut and connected into. So it actually breaks the wire and connects into it. That's the one there for the that one gets connected to for the EV switch. So one connection to that and one connection to ground. And that one there, that black wire there, is just happen to be both black. That one there is in a different connector. That one's, you cut that and you place wires in series with that, and that becomes your engine cut switch. And there they are there. That's before I installed the front box. I use these little miniature Anderson connectors. They're very good because they're both male and female, so you can connect them both together, which is good. So for that one there, that's the engine cut switch. So before I put the box in, I had to connect them together, otherwise the engine won't run. And that's for the EV switch. So that basically pushes the EV switch for you. In America, they actually don't have an EV switch in their Priuses. They've actually got to install a kit to put the switch in. So we're lucky here. And that's the box sitting on the front hump. And the wires disappear underneath this little cover here, nicely. Okay, installing the charger. This is to just go quickly through this. I haven't given you all the detail here. If you want to go on my website, EV Plus, you can see a lot more photos with a lot more detail. But that's where the charger's going, in that little hole there. It's a pretty useless little hole. I mean, it's just good for storage. If you've got a big pusher or something, the handles can go in there. Underneath this little cover here, there's a little empty box you can put your first aid kit or something in and your windscreen cleaner. Okay, I had to work out the position of where to put the charger. The charger weighs 7 kilograms, and even with assistance from Steve, I couldn't hold it up. We couldn't hold it up in position to try and work out how it was going to be mounted, how to mount it. So I found a cardboard box very close, very similar size, and another flat sheet of cardboard. I made up a bracket out of the cardboard. I stuck these little polyethylene blocks on there from the packing of the batteries. They're representing the 3 fans. I have to have fans because I'm mounting the power supply 90 degrees to how it should be mounted. So I've got to have air rushing across the heat sink, as you'll see later. So it was really great having a cardboard cutout. I could just keep cutting the cardboard until it fitted, and even add cardboard on. You can see I used hot glue to do all this, and just add cardboard onto it and recut it until it fitted in. And it just so happened that is there one that doesn't show on the website? You can see it better. There's actually a seam coming down here, a double seam coming right down there. It goes across there, of where the body panels on the Prius join around the wheel arch. And possibly the petrol tank, actually. No, petrol tank. Petrol inlet. And I was able to put some riv nuts in there to hold the bracket on. And then I bolt the charger to the bracket. You can see it there. That's one of the connections there into the riv nut into that panel. And there's 2 more there and another one at the bottom. The one at the bottom worked out in a great position. It actually ended up being right in the right spot for one of the bottom bolts of the charger. There's two at the top and 2 at the bottom. And so the bottom bolt has got a double purpose. It actually holds the bracket to the car and also holds the charger to the bracket. Now this bottom bit was a bit interesting too, because when everything's together and the batteries are in, it's very hard to get to these bottom 2 screws. So what I did, I made them captive by putting some nuts on the back, and so they're actually held just the right distance out, so that the bottom of the charger just slips onto those 2 screws tight. Yeah, it looks easy. It wasn't. And so you can see there the 3 fans mounted on the bracket, and they blow across the heatsink to keep the thing cool. and that's it. That's with the fancy panel put back in. That was very interesting. Had to cut that panel, of course, to fit it around it. You can see it cut there. And even around the bracket, there's actually a bracket sticking out the top here. But we managed to cut it in such a way that it just went around that bracket. So nice. It was good that Steve was there to help me with that. And we had the Stanley knife out, and I was about to hack too much, and he'd say, "No, you don't have to cut that much off." And it went in really neat. And it's actually, I don't know whether I got no, I haven't got a photo of it, but I've got another photo on the website looking from the back of the car, and the surface of that heatsink, front of that the end of this surface here of the heatsink is actually well back from this surface here, so it's right out of the way. You'll see it after anyway. Charger specifications. It's a, I haven't got it there, it's a TC charger, TCCH charger, 2 kilowatt charger, set to match 76 lithium-ion cells. There's actually a bit of a story to this charger. I ordered one from China first, told him I needed it for 76 lithium-ion cells because they've got to do it in the factory. They set it all up inside in the factory. Yeah, no worries, no worries. Sent in the money, charger arrived, opened it up, not set at all, off the shelf. And also it wasn't even I wanted one that was an enable one with just 2 wires we joined together and turns it on. I ended up with a CAN bus charger. So there was a big story. That ended up going over to EV Power. I got my money back from China, and then I rang up EV Power and said, "Can you order me a TC 2 kilowatt TC charger set for 76 lithium-ion cells?" He says, "Oh, you can get it direct from China." I said, "No thanks." I wasn't going to go through that again. So it pumps out, 277. I think I've checked at the end of the charge, about 276.4 or something, and by that stage the current's right down to say half an amp, which is absolutely perfect for these cells. So the end of charge is 3.65 volts per cell, which seems to be the figure everyone's looking at now. Unlike when I did my car, everyone was talking about 4.1 until we learnt better. So 3.65 volts per cell, and maximum charge current starts at 6.3 amps. Puts out 2 kilowatts with an efficiency of around about 93% or more, actually. Okay, heavy duty springs. Now we're going to add another 120 kilograms. Did you want to ask a question?
Just on that voltage, on your first slide or second slide, you mentioned 500 volts.
Yeah, and I also mentioned there's an up converter. There's an up converter in the Prius to up it. Voltage doubler.
So the 500 volts is the voltage up that's gone through the up converter?
Yep, and that runs the whole electric system.
So what is the actual true terminal voltage?
It's normally, because it's nickel metal hydride, they normally say 1.2 volts per cell, which is 216 volts, but it's never at 216. I've got a monitor on the Prius, and it's always between 220 and 260 something. So it's okay. The heavy duty springs, I'm adding about 120 kilograms total. That's after things have come out and things have gone in. Worked out 120 kilograms extra in the back full time. So I decided that I would put some heavy duty springs on it as recommended, and King Springs supply a standard one, which is the KTRR 106SP, but they had no data on it. They couldn't tell me whether it was going to be good enough or anything for this particular car, and I can tell them all about it now. That's the replacement on the left, and that's the replacement on the right. And there's nothing special about them. They're just a little bit thicker, a couple of millimetres thicker steel, and a little bit shorter actually. And these are the figures I only got last week. you'll notice that, of course, they're only affecting the rear. Front left, 368, 368, 368. Front right, 367, 367, 367. Rear left is interesting. Standard springs, 355. Went up 25 millimeters before I started adding the batteries. And then 357 with all the battery and everything, the whole thing installed. So it's 2 millimeters higher at the back than it was when it started. So I reckon that's pretty good. And 2 millimeters is really hard to measure on the hub, because the hub's got a circular center, and then it's got the Toyota badge in the middle of it, and you're trying to work out where's the center. So 2 millimeters is nothing. Yeah, so that was very interesting. So I can tell the guy at King Springs that yeah, they're perfect for 120 kilograms. Here's the battery frame. In the later stages, just getting a coat of undercoat. 20 by 20 by 3 steel. And then I used my own system of holding the batteries down. I didn't want too much height above the batteries. I didn't want any extra height above the batteries, because I wanted to be able to still have the mat low down in the car, so that when it's all together, you hardly notice that the batteries are in there. So I used my own system using these threaded rods, and if you look carefully, you can just see there, there's a 1 inch, what they call a mudguard washer, and then there it's got a split washer with a nut. I actually end up using a nylon washer. And then there's a bit of a gap, and then there's a washer silver soldered to a nut upside down, so that the washer's on the top. And you'll see in one of the other slides how I've now got felt all around here and on the top of each of these washers. The idea of that is that's adjustable to match this height here perfectly, so that when the polycarb sheet clear polycarb sheet sits on top of the batteries, it's supported not only by the outside but also by 27 threaded rods, which are very, very stable, because they're actually holding the batteries down, so that there's no movement there. And the batteries will hardly move anyway. Just ask Steve how the trouble we had putting the batteries in. On the right hand side, oh yeah, with the lithium-ion prismatic cells, which these are, you're supposed to clamp them up. Okay, if you just put them in loose, well, that'll be okay. If you do have something go wrong, they can start swelling. Okay, they shouldn't, but they might. If they start swelling, then what happens is you can't get them out. So, you know, you're stuck. If the case is a fixed size and you've got all the batteries in there and they swell, that's it. They jam in, you can't get them out. You'll have to hack the case apart. So what I ended up doing was putting an aluminium plate right on the right-hand end across all 4 rows, and then I just put these welded nuts onto the bottom frame, onto the middle bar of the frame, and they push on the aluminium plate and clamp the cells. So the cells are held very firmly that way as well as being held down. That plate is over here, which you cannot see because it's just under the frame. So they're all clamped up against the other end, the other fixed end. So there you can see all the threaded rods sticking up without any nuts on. That was where it took a couple of hours to do that. Steve was helping me getting them all lined up. We had made little wooden wedges to try and push them up and line them all up, and so because they've got to fit in between those threaded rods and also line up with each other, which was pretty tricky. Okay, then we got the all the washers on, bolts, nuts and washers, holding them all down, and all of the felt covered washer nut assembly on the top. And each of those was put a little bit of Loctite, very, very weak Loctite in there, put on and then levelled with a straightage across the top of the whole lot, each one. So that's perfectly level across the top. Okay, what's the difference there? Okay, we've got all the connections and BMS modules in. That was a very, very time-consuming job. Was that the... I thought there was one in between there. There's obviously not. That's just a close-up of the connections, so you can see the interconnects. They're tin-plated interconnects directly on top of the terminals. Take note, anyone building an electric car, the interconnects have to go directly on top of the terminals. BMS modules on top of that, and any other wires on top of that. Each of the connections, the terminals and the interlinks are all brushed with a little brass wire brush, and then coated with a no-oxide grease prior to assembly. The grease ends up being slightly yellow, or nearly clear, which is good, so it's not messy. So each of those has been done. That was very, very time consuming doing all that. Of course, as you're doing all this, you have to wear a plastic watch. And keep all your tools covered with heat shrink. Dennis? I suppose it's my fault. I lent it to him. I didn't have it covered. I should have had it covered before I lent it to you. But I didn't have any... I think I had one little wire brush at one stage. It's only a little, very short little wire brush, but it got between two terminals and just had a little bit of a... It would have only been like 6 volts. Yeah.
Stainless screws?
Yes, they're stainless screws.
You put anything on them to stop them?
But everything's coated. Every surface that you see there, the battery terminal, the underside of the interlink, the top side of the interlink, the washer. There's a washer and a spring washer.
What about the screw thread?
And the screw, no, that got a bit on it.
Stainless will actually see.
Yeah, no, it got most of them got a little bit on them as it went in through the hole, because there's grease in the hole.
Eric,
Yeah.
do you also use Loctite in the screws?
No, I didn't use any Loctite on these. They're all tensioned down to 9 Newton meters with a tension gauge.
Yeah.
Got a nice new tension gauge, yeah.
And you have a spring washer as well, or
There's a spring washer, yeah.
not expensive, no locks?
Nord, I looked at Nord locks and they are so expensive. I might have looked at the wrong ones, but
Double.
I might have looked at the stainless ones, but evidently the ones that Jack Rickard's supplying are only zinc plated, I saw the other day. But Nord locks are the way to go if you can afford them. Nord locks, they've got a special 2-piece washer which digs into each surface and then also interlocks in each washer. And they sort of go up a little ramp and then drop down. So it's very hard to get undone if you ever needed to. I numbered each of the cells. I took measurements, voltage measurements of each of the cells before I interconnected them. They're all within 22 millivolts of each other, the whole 76 of them, which is pretty good. And that's what it looks like now. So under there is a clear polycarbonate sheet on top of the batteries. This mat is a Prius mat, which you can't buy in Australia. It's made specifically for the Gen 2 Prius, but no, they haven't got it. You can't get it in Australia. So I ordered that on eBay from an American Toyota dealer, basically, on eBay. 150 bucks. Well, actually, when I inquired, he said, "Oh, we got one for the Gen 3." I said, "That's no good to me." And I said, "Oh, how much is it?" He said, "About 160." I thought, "Oh, 150, which includes like $60 freight," I thought was quite good. So now we've got to make it plug-in, don't we? So I decided to use a Caravan 240 volt 15 amp inlet. I use 15 amp because I've got 15 amp on my electric car, so standardised on cables. It's only, you only need 10 amps really, but 15 amps most common anyway for these particular sockets or plugs. So it comes with a little foam packing things, so you just use one of them as a template. Use a Texticolor to draw it on the bumper bar. Before I did this, I took off panels. It's on the website. There's a plastic panel to take off, and I put my hand up inside and felt around. There's just nothing in there. You can put it anywhere in that spot. There's just nothing there. So I just thought, oh, that looks about sort of in the middle of that sort of area. So I did that and tried to keep it vertical as much as I could. Very difficult because there's no horizontal lines on the back of the car. You know, they're all sort of all curved.
Well, you wouldn't be the first one that drilled right through a wire loop.
Yeah, no. There's nothing there.
It's a disaster.
So yeah, then you just get the Dremel out and hack it out. Just get the right speed so it doesn't melt it too much, and just grind it away. There it is, all cut out ready. And they're the only bolts I had. I didn't worry about cutting them off. They're stainless steel bolts and stainless steel mudguard washers, just to spread the load on the back of the plastic panel a bit. And it's all wired in. And that's what it looks like on the outside. I think it had originally underneath charge port, it had 240 volt inlet or something, so I just put labels over the top of that. Things not shown in this presentation. Okay, well, I've got a fuse which I put in I've got a piece of water pipe, found some rubber bungs which fitted in the end of it, and I haven't got photos of that as yet. And put the fuse in. It's fairly hefty fuse. I don't know what style they are, but it's 125 amp, 600 volt. I actually got two on eBay. Made sure they weren't used. They were used, but they were still good. Yeah, I got two on eBay for the same price as one you can buy in the shop, so that was worthwhile. Also, an amp hour meter called the JLD 404, wasn't sort of around. It might have been around, but I didn't know about it when I built my electric car. But it's a very, very good meter, and it's they're only just over $100 from America, including freight. It's got ampere hours, it's got volts, amps, time. I think that's about it. That's about it. And you can set the display up to step between each of them, so you don't have to sort of push the button to go between each of the things. So you can see it changing from one to the other and take all the readings down as it goes through. So it's with any car that you've got lithium-ion batteries in, you need an ampere meter, right? Otherwise you've got no idea of the state of charge. And people have found that by driving and then stopping because the batteries are flat. This tells you exactly how many ampere hours you're taking out of the batteries, and the good thing about it is with the power off, it stores the values so that in between driving this thing and charging it, the JLD 404 is actually off, not powered at all. When the power comes back on, all your readings take off from where they were before, even your time and your ampere hours. So what I did with this, when it was fully charged, I reset on the JLD 404 to 0. And so my ampere hour meter now shows discharge in ampere hours. And so at the moment, I've only ever been down to about 24 ampere hours so far. But then you put it on the charger and then it goes backwards, of course, back towards 0. And it does, it goes right back, and fully charged it was something like 0.02 ampere hours or something, which is pretty good to be able to come back to 0, you know, after all that. And then the associated shunt, I put the shunt in one of these plastic PVC pipes as well with the rubber bungs, and you drill holes in the rubber bungs. Rubber bungs, they're not designed to go in these PVC pipes, but they fit really nice and tight, and it protects it all the high voltage. And paint them orange, paint the PVC tube orange, and it looks like it's meant to be there. And they just basically hang off the end of the battery frame. All the wiring connections are not shown in this presentation, and also the hours and hours of work. Weight out, weight in. Remove 20 kilograms, which includes the spare wheel. Spare wheel comes out, stays in the shed and then if we have a problem, we upped our RAA membership to premium, so we can get towed for further. I think it's 100 kilometres in the metro area. Also put in a one of those compressors with the goo. Yeah, slime. What do they call it? Slime. And the compressor, you can, if you just need to pump it up to bring the pressure back, you can just use it just like a normal compressor. But if you've got a very small leak from a nail or something, you put the slime in and it fills up the hole and you pump your tyre up. I'm not too sure what the tyre guys think of this, but it comes in a nice little plastic bag, and it goes. I just fit it under the front seat, so it just gets out the way. Spare wheel goes. All the tools sort of stay with the spare wheel, and I can take that to my wife if I can get there, if I'm within range, if she has a problem with one of the tyres. The rear floor deck box is a great big storage box that I don't think Prius owners know that it's there. It's an enormous thing. You could put a lot of storage in there, a lot of shopping in there. And the rear floor board, that's now I've replaced that with the carpet. That was a plastic board, 25 millimetres thick, folding in the middle, so you could sort of fold it up and get into your plastic tray and fold it back down. So I got rid of that, got rid of 20 kilograms there, and I added 140. The steel battery frame, I think that was around about 11 kilograms, plus the 76 ampere hour cells. Front control box, rear control box and contactor box weigh, a few grams. But total cost, I knew someone would ask me that, so I thought I'd better put that up there. Around about $7,800. Plug-in supply equipment, front box, rear box, contactor box and cables, around about $1,500. I think his freight costs started out at $20, and by the time I got to the second box it was $50 because he realised he wasn't making any money on his freight. But it's still reasonable. The batteries and the interconnects, $4,600. BMS modules, $1,034. Rear springs, $200. Plus miscellaneous, $500. I got no idea on the miscellaneous, but I think it cost me about 100 and something to get the springs fitted, and there's just so many things you just keep going back to J-Car for. There's plugs and sockets and bits of wire, and I've got my rewards card now for J-Car, so I can get a discount after $200 spending. And the steel for the battery frame was around about $40. Anyone got any questions? Yeah.
About that spare time, it's if you get stopped, you get a defect.
No, you don't.
No.
No, you don't have to have a spare wheel in a car.
Really?
No. No, there's no law that says you have to have a spare wheel. No, there's not. Well, see, electric cars. No electric cars have got spare wheels. And the Holden Volt has not got a spare wheel.
No, the smart car doesn't have a spare wheel.
No, there's no rule saying you have to have a spare wheel. Yeah.
How do your batteries charge and discharge? So you obviously don't work as parallel. Do they sequence or?
The 76 cells are all in series, and they get switched in parallel with the OEM battery.
But you said the OEM battery was lower voltage
No,
than that.
not they call it a nominal 216 volts, but it varies between, according to my voltmeter on the dash, it varies between about 220 to 264.
So you just parallel the batteries?
Yeah, they just get switched in straight in parallel. Yeah.
So they will charge off your motor?
Yeah. Yep. If regen's happening at the time where they're connected, it'll get regen into there. But like I said, what they try and do is keep the batteries at 62%. So the contactors are continually being switched on to bring the voltage up. You can actually see it on the meter come up to about 260, and then it reaches that, goes off, and then drops back down. As soon as it reaches about 210, 215, the contactor goes back in. So it's continually cycling the battery. So it's actually working it just like the car would work it normally. So the battery's been looked after properly.
Just to follow on the question on that, Eric, you said you've got an hour meter to provision the discharge.
Yeah, and charge.
The way you reset it is brilliant. Roughly how long does it take you to charge the car up, and roughly what sort of mileage do you do for that?
Depends how far down you take it. The question was how long does it take to charge the car?
On average, ballpark figure.
Well, we're only using say 32 ampere hours of the 40 ampere hours. Right? I don't want to go below 20% state of charge, and it's a 2 kilowatt hour battery. So if it was dead flat, it would take. Come on, you mathematicians. Would that be 16 hours if it was dead flat?
10 kilowatts.
Sorry, 8 point. Oh yeah, 8 point. No, and we're talking about ampere hours. Yeah. Oh, kilowatt hours. It's 2 kilowatts. Oh yeah, sorry.
You get 2 kilowatt.
Yeah, say it was eight kilowatts. So 4 hours.
Yeah, except the second half of charge of lithium-ion tapers right off.
No, it's not the second half. I should have brought that with me. I've got a curve of the actual charge. It's only the last 10 minutes it really tapers off on this particular. It depends on your charger, but they tend to go up to it, and then the voltage starts rising rapidly, and in that rapid rise, that's where the current gets tapered off. Yeah.
You've made any inquiries on insurance implications, whether or not you actually altered the vehicle?
The question was about insurance. I'm with Shannon's already, and I am going to tell them about it. They probably won't care at all. It's just an add-on battery. So it's the same with the Registrar of Motor Vehicles. I actually applied with my form, changes to modifications to a motor vehicle. They wrote back and says, no, you don't have to do anything with us. You're not affecting the drivetrain at all. So they're not interested at all. Sorry? Yeah, I've got comprehensive on it, but I will have to take it down there and just discuss it with them and
Yeah, because if you have a crash, they have to pay for your batteries.
yeah. I'll talk to them about that. I'm going to talk to them about that. Yeah. Yes.
You're saying the new battery and the old battery are permanently connected in
No.
in parallel, or they?
No, via a contactor, and it gets switched in and out, on, off, on, off, on, off. Charges it up, charges the internal one up, and then when it gets to a certain voltage, the contactor opens. The main battery, the big battery pack, is not connected anymore. So it cycles.
Oh, okay.
Yeah.
So how does that work with regenerative braking if you have a large descent? Does
If the
charge the new battery as well? Only when the contacts is on?
It's not going to get as much as I thought it might when I first thought about this, because it only charges because they're in parallel, or not. See, the battery is kept. The OEM battery is kept at 80% charge. So when you're going down a hill and you're regenerating, you probably are still going to waste some power. Not if the voltage gets up to 264 volts. As soon as it gets 264 volts. Oh, some of it might, yeah. Some of it will get wasted, and some will go into the lithium iron phosphate batteries. Yeah. But as soon as it gets to that voltage, the contact will be switched off anyway. Yeah. So not much gets back in. You don't have to. You got 10 kilowatt hours of battery there.
But you could arguably start off with a flat low level battery.
No. Why would you want to do that?
No.
Oh, you mean the OEM battery?
Or even one.
No.
You live up the top.
Well, that'd be silly. That'd be silly starting off with a flat additional battery, wouldn't it? Talk to me after. That doesn't make sense to me. Next, yes.
Venting. Do you need to vent your batteries, or you got any plans?
Lithium-ion batteries don't need any venting.
Any heating? Do you need to get any?
Lithium-ion batteries probably raise 2 degrees degrees centigrade on charge. So they're not really on charge much during driving. Yeah.
Winter's here. Does the air conditioner heat the car, or does it?
Oh, that's a good point. I looked it up when we first started using it. Because the petrol engine's not on much, the heater takes ages to heat up, and my wife was complaining because it normally uses engine heat to heat the car internally. But I looked it up, and the Prius has also got electric heaters as well, which is good. So all you got to do is turn the temperature up higher, and they come on, and heats the car up. It's quite acceptable. Yeah.
Another thing, if you would have charged your car where it would be finished sort of early in the morning,
Yep.
then the car would already be warm from the cooling of your charger. I mean,
Yeah, slightly. Yeah, it would be slightly. It depends on when it turned off. Yeah.
you got those 3 fans that sort of blow.
Yeah, it'll be slightly up. For sure. Yeah, I haven't actually got it connected to off-peak yet. I'm just using normal mains because I've been using normal M tariff because I want to sort of be there while I'm to record the voltages and so forth. Very interesting actually about the charging. The first charge was terminated by one cell which reached the voltage of the high voltage limit of the BMS module on it, and that opened the loop going to the rear controller which turned off the charger. So the charger's got a connection through to the rear controller as well. The second, excuse me, the second charge, none of the cells reached the top voltage, so they were starting to balance already, and the charger current dropped right off down to less than 0.5 of an amp, and there was 26 of the red balancing lights showing on the cells at that stage. That was on the second charge, and all subsequent charges, none of the cells have reached the top voltage. So it's really, really good, particularly when there's 76 of them. You know, so it's a lot of cells, and because they were when I first got them, they were all within 22 millivolts, but they'd been sitting around for quite a while on the bench, not being used. Yes.
So, did you say when it's fully charged, how many kilometres does it do?
Around about 80 kilometres, I'm guessing. Yeah. That's just on battery by itself, but with the hybrid assist type mode where you're using battery, a lot of battery and a little bit of petrol, it's interesting. I think on the first day I only used like 2.5 kilowatt hours or something of the battery. So you go for quite a few days before you even got to charge the battery up.
That means it's going to last pretty long.
Sorry?
That means that the battery
Yeah.
lasts quite long.
Yeah. Yeah, it's really good. So I'm hoping that it'll be, on a long trip, I think it's going to be very interesting to see what happens. So it'll be sort of battery assist most of the way, and you can actually feel it when it's using the additional batteries. It just sort of gives this little like surge, and you can sit there on 100 k's and it's just all electric. And as soon as you put your foot down a little bit hard, a bit of a hill, petrol engine starts up again. But, yes, sir.
Have you got, with your BMS, have you got a maximum discharge rate set into?
The question was the BMS modules, do they have a maximum discharge, like a balancing current?
Yeah, I want to know how much.
It's fixed. The BMS modules bypass at around about 600 milliamps, which is sort of the same current as the end of the charge cycle. All they do other than that is monitor the voltage on the cell. So
you've got a 50 kilowatt motor, but that wouldn't be supplying, be capable of supplying 50 kilowatts of power to it.
Instantaneously, yeah, it can. it can supply 100. The batteries will supply 130 amps. That's about without any problems. Yeah, 2 or 3 times their C rating. Yep.
So now, your dynamic as far as the internal combustion engine is concerned, that's inhibited from operation. Normally they cut in at what, 32 kilometres an hour.
Yeah.
And so that's now changed?
Yeah, the system actually keeps trying even after the 43 kilometres an hour is reached. In the past, a standard Prius will get to 43 kilometres if you've got very light pressure and your EV switch is pushed. It'll be electric right up to 43. As soon as you hit 44, petrol engine starts up. In this case, I've seen it actually continue in EV mode above 43 because the front controller box is continually trying to change it into EV mode. It does it very well.
So at what speed then is the internal combustion engine?
It doesn't work on speed. It's just the power required. So if the engine senses that the system senses that it needs more power to push the car along either high acceleration or hills, and then it says, okay, I need the engine in. I think they've got some sort of parameter worked into the power rating to do that. Any other questions? No, that's it.
Okay, thank you, Eric.
Thank you.
Thank you very much.